Eh,
Okay, sure.
eh. Hold on one second. Recording is not begin for some reason. Oh yeah, it's begun. Um, Everyone, let's welcome Bikram. Bikram joining us from Kathmandu. Is that correct? Are you in Kathmandu right now, Bikram?
Yeah, currently I'm in Kathmandu.
Um, and he's the CTO of DocSumo for the last 3 years. And he founded another startup, AI ML startup before that. And he's agreed to talk to us about CI/CD, which I'm sure is every developer's dream. So please take it away.
Okay, sure. Thanks, Siva. So hi everyone. It's me, Bikram. Like Siva have already given an introduction about me. Before DocSumo, we were running a consulting company, and later on we started with DocSumo. The main focus of today's talk is like we have a robust CI/CD pipeline in DocSumo, and we wanted to share our learning because it took us a lot of iteration to get to this pipeline. So we wanted to share uh, what are the problems that CI/CD pipeline can fix. What are the learnings that we did so that you guys do not have to make the same mistakes that we did, and what are the best practices that we have followed. Along with that, I'll also be sharing some code snips which you can which you'll be able to take it, and if you guys want to implement it on your organization, then we'll also provide you that resources. So let's start with introduction. Regarding DocSumo, DocSumo helps company automate their document workflow. So you might have done it yourself, right? You get a lot of document, and this document either comes as image or PDF, and you have to convert this document into JSON structure or CSV, which is currently being done manually. We wanted to make sure that this stuff is the manual process of entering this data, converting them into digital format is minimum. So we help enterprises like Baidu, Patience, and Arbor.com and other companies make sure that they can use AI, ML, and automate their information extraction decision making. Right. So let's talk a little bit about my coin team and why did we invest heavily on CI/CD pipeline at the very beginning. Right. Currently, I have a team of 16 engineers based out of Nepal and India, and we maintain about 50 different repositories. Right. We have microservices architecture for majority of our infrastructure because, like I said at the beginning, what we do is we help enterprise automate their document, and the list of documents that they might have can vary vastly. Some of them have KYC, some of them have bank statement, some of them might have pay slips, right? And for different vertices, we have different APIs. So that is the reason we have so many repository because we have about 40 different document type we currently support. Along with that, we also support some custom document type. You can come to our account. Do few annotation, train a machine learning model, and your API will be ready. Right. For all of this, we only have two backend engineers who do majority of the tasks for our app. We have a web app, and we also have a direct API. So we have two backend engineer, we have two front-end engineer, and yes, 12 of them are ML and data science engineer. Right. Now, one of the things that you guys might have heard is that in data science, only 20% of research goes into production. But that cannot happen in DocSumo because we are really like heavy on AI and ML. And 12 of my people are on ML and data science. So I have to make sure that my CI/CD pipeline, my DevOps is very strong so that the 80% of the resource, the project that they do has to go into production. Otherwise, the ROI is not enough. So for that reason, like we have made sure that like we have invested heavily on CI/CD pipeline. We have tried a lot of things and come up with one architecture that works for us, which I'll be sharing on this call. But there might be like you will be able to make certain tweaks into this CI/CD pipeline that we have, or follow what works best for you. Because later on the conversation, I'll let you know what is our current tech stack and why do we have the current CI/CD pipeline. With this information, you guys can take it and build one for your organization, right? We don't have anyone on the DevOps because majority of the DevOps is currently handled by me alone. The reason I handle it is, first, majority of the things that I need is fully automated, right? The CI/CD is ingrained in the company's DNA, because when an intern joins a company for the first time, right, we make sure that he has a lot of things to learn, but one of the important things, even he is just working on research, like he's not doing anything else, he is with us for 3 months. Even in that case, the first task we give to them is, your job is to put one feature or one API. Usually it's a production ready API, but sometimes it's a dummy API depending upon the cycle and everything. We make sure that they understand everything end to end, right? Even if they are only with us for 3 months, because we need to make sure that everyone understands how things. Once you write a piece of code in DocSumo, they have to see it has to go into production, has to go into deployment. That is a number one priority that we have for everyone. And like I said, CI/CD, each and every one on the organization should know it, and it's a philosophy. It's not job of one person. Whoever writes the code, it is his responsibility to make sure that it has gone into production. So we make that their responsibility. We provide them the best tool that we can provide, we can provide to them. We provide them the templates so that they can have that, have their code into production. Right? So this is regarding the team. Um, Let me discuss a bit more about what are we going to discuss today, right? Today we are going to discuss about what are the problems that we were facing, like why did we invested heavily on CI/CD pipeline? What are the problems usually as a developer you guys might be facing, right? And if you want to solve this problem, what are the infrastructure and what are the tools that you need? We'll talk about our current setups. We'll also talk about our best practices, like we have in place, and we'll talk a little bit about our learning, right? Where did we made a mistakes? When I discuss about CI and CD, now CI means that I'll come to that on the next slide. So as a developer, or as a manager, these are the major problem you guys will be facing. Merge conflict. No one likes merge conflict, right? Everyone hates that. So one of the issues that every one of you guys will be facing is a merge conflict, because the task you do is not on isolation. It has to be merged with other code. And merge conflict can be really tiresome. That is one. Second thing is inconsistency on your code quality. If you're writing, let me say, Python or JavaScript, even if you use lint, right? Even if you just use some automated tool, some static code analyzer, or let me say you use some kind of lint, if these things are properly done, then even just doing that two things, right? Not having very complicated systems like unit test, load test, and everything. Even if you just have these two things, then your code quality will be a lot better, right? That is what you like. One problem is that the code quality is not consistent. Third thing that you usually face is you have best practices, right? You have, like in case of Python, you have pip8, right? And other language has their own standard. And these are best practices, but usually people don't follow it. And you don't have a way to enforce it, right? How do I enforce to make sure that if someone is pushing a code, it should always have a test? How do I make sure that the code quality, right, based on the static analysis or based on this thing, if it is not more than 80%, then I'll not allow you to like deploy it. Or if the duplication on the code is more than 2%, I'll not allow. Your job is to first fix it, then only I'm going to allow it to merge, right? So how do I enforce all of this tests? And the fourth one, like the fifth one, is when you have to do a deployment, right? You don't want to be going to like all of these engineers who have like push variety of this code, have one meeting with them, spend 2 or 3 hours, and then then do a deployment cycle. because deployment cycle should be very easy to implement, right? So you don't want to spend that much high amount of time. And the fifth issue that you usually face is sometimes you have to send a hotfix into your production branch. Sometimes you might have to do a rollback because we are going to screw up. We are developers and we are going to screw up. It will happen to best of us, right? So we need to make sure that there is a faster way to deploy a hotfix and faster way to do a rollback, right? And the last issue that usually happens is that because everyone is working on so many features, if you don't have a good CI/CD pipeline or good process in place, then you will not be able to do a release cycle as per what you have initially planned. And all of these are the majority of the issues that you guys will be facing when you are trying to deploy your code into production. So these are there might be other issues also, but these are the main issue that CI/CD can like solve, right? So let's talk about this problem. From 1 to 4, the problem is focusing on before the code is like deployed into your testing environment, you want to make sure that best practices are in place, right? There is a test coverage, there is like a lot of things, right? This is the part of continuous integration. What does continuous integration mean is that when people are working on different branches, we want to make sure that people can easily merge these two code that they are working on, and then they want to make sure that this is ready to be built, right? This is ready to be made into some artifacts which can be deployed, right? The process of automating that step is usually called continuous integration, right? People can easily like integrate, right? Any piece of code, hit push button, everything will be test, and if everything is good, or artifacts, either Docker file or some binary would be built, right? Making sure that you have everything on to make sure that this whole process is smooth, you have very less merge conflict is the part of continuous integration. That is continuous integration, right? Once that file is built, then like you have to take that and deploy into different environments. That part is handled by continuous delivery, because once that Docker file is made, or once that image is made, or binary file is made, or in case of React, only the files are made, the next job is to make sure that you can easily deploy that into different environments, conduct various tests, and if everything is good, you want to be able to push it into production, right? That whole process should be smooth. That is handled by continuous delivery. There is one more concept called continuous deployment, right? I'll just go very short into continuous development. Continuous deployment, the difference between continuous delivery and continuous deployment is that in case of continuous deployment, what happens is that on case of continuous deployment, people do not have to be involved at all. In case of continuous delivery, there is one person, usually it's called change management. Before something is pushed into production, there will be one person who is responsible to either manually push that information or have certain steps within the organization to be completed before that can be pushed into production. That is a part of it's automatic, right? It's fully automatic. The step is usually the manual step is just pressing one button, right? In case of continuous delivery, that is the case. In case of continuous deployment, no human is involved, right? You push your code, it will go into production, right? After doing everything. And that is not something I'm going to focus because I have not implemented that kind of system, but I'll be focusing on continuous delivery, right? Where there will be at least one change manager or developer, whose job is to manually put, once everything is ready, to manually push the code from your staging environment into production environment, right? Am I clear till now? Can you guys, everyone can hear me, right?
Yes.
Okay, so just want to make sure that I'm not talking to myself. Okay, so today's we'll be focusing on continuous integration and continuous delivery only, not on deployment. Okay, now you guys understood the benefit of you guys have a problem. right? You guys know that CI/CD might be a good solution for you. Then what are the things that you need to start setting it up on your organization? The first and the fundamentally the most important thing that you will need is you need to make sure that you have at least 3 separate environments to push your code, because once the CI/CD pipeline is completed, you don't want to directly push it into production. At least minimum. Sometimes even people have up to 5. I have seen people having up to 5. But no matter the size of the organization, either you are 1-person team or you are like 100 people team, the minimum 3 environment, no matter if it is like a serverless, Kubernetes, it's a VM, whatever. It do not matter what infrastructure that you are using, right? You should have minimal 3 environments. Usually it's called QA staging production. In our case, we call testing staging production, right? No matter. Then after that is done, you need like a CI/CD tool, right? You need a tool that can do CI/CD. You can use any tool, right? It can be GitLab CI/CD, Jenkins, GitHub Action, and there are 50 other tools. If you need, how do I choose, right? So as an engineer, like you will always face this issue. You have so many choice. You have like so many choice, and you have to choose one tool. There's a link with this one. There's an article that really explains like different kind of CI/CD pipeline. What is their benefit? What is their limitation? Everything. Right? This is the best article that I have seen on how to choose which pipeline to choose depending upon your requirements. So you guys, after this one, I'll show you the slide. You guys can go through that, and then you can choose which you want to choose. But no matter what you choose, as long as it's usually they have the same concept. The concept that they have is you are trying to solve that 7 problem I showed you at the beginning. First is environment, second is tool, and the third is you need to have artifacts, right? How we are going to deploy these things. It can be Docker, it can be file. Like I said, in our case, we use Python, so we usually use Docker, right? You can also use binary with Docker. Example, if you're using Go programming language, C programming language, it can be a case. If you're using React, you can also use files. But all of this is either Dockerized. Usually it's Dockerized, but it's not absolutely required. As long as you know what is the artifact that you want to deploy, you should know, like you should have an idea about that. And the most important, right? Infrastructure is tools you can choose. Artifacts, you will have a best practice in place. The most important thing that you need to have in place is a process that people can follow, which will be the focus of next topic. Right? This is what is required for you to have very good CI/CD pipelines. Let's talk about our current setup, like how is everything deployed. We currently have 3 environments. We use GitLab. The reason we use GitLab is like it comes with its own CI/CD pipeline, because GitLab is supposed to be whole DevOps tool, not just repository. And we really liked that from the very beginning. And they also allow us to run the CI/CD pipeline on our own infrastructure. So they were a single tool to handle everything. So because of that, we went with GitLab. But it do not matter if you are on GitHub or if you are on Bitbucket. Like you guys can use one of these. On our case, everything is deployed as Docker image, because my tech stack is just Python and React. Right? We just use Python and React. So we always use image. Like at the end of your CI/CD pipeline, our image is made, and that image is deployed into any of this environment. We mostly have our infrastructure on Kubernetes and Cloud Run. Cloud Run is a serverless architecture which can deploy Docker. So we had an option to go with AWS Lambda, but we went with Cloud Run because Cloud Run you can deploy your Docker, same like you deploy your Lambda. I know that AWS Lambda also has started doing it about a year ago. They allow you to do Docker and everything, but we had done this about 2.5 years ago, and Cloud Run was the best option that we could have, so we have gone with that. And about 5% of our workload is on function and AWS Lambda, right? So this is the infrastructure, and our release cycle is usually 2 to 3 weeks. So this is our current setup, right? So let's go like up to here, any questions do we have, or like we want to have a question answer session at the last, or we want to have like in middle? Siba, like what is a good?
I think people can just add questions in the bottom right, no? Whenever there's a good number of questions, you can sort of take a break and answer them. I think that
Okay,
is probably.
sure. Okay, sir. So let me check. Okay, that's good.
Yeah, I'll let you know if there are a few
Sure.
questions in the future.
Okay, sure. So let's come to what is our coin setup, right? So I talked a lot about problem. I talked a lot about what are the infrastructure that is needed. Now let's come to like how is our coin set up and why is it set up the way it is set up. And like I said at the beginning, this is not only way of setting up. Your system might be a bit different depending upon what you need, but this is the base that we have figured out. The CI/CD, even the CI/CD pipeline or the framework, that idea of like whole CI/CD pipeline is just even before you commit a code. In our case, right? Usually people think that CI/CD is going to start when I first commit my code. It is going to pick up. It's going to do a test and everything. No, like I said at the beginning, the CI/CD, that concept of making sure that you have everything in place should start before even you do a commit. For that, what we usually do is before the commit, there are certain tests that can be run locally without using too much of your resources. Example of this is you can check for syntax, like usually like people do check for syntax, but you can also do a type check and you can also do lints. Right? You can make sure that you can also do lints. Along with that, you can also do some static code analysis. Right? Sometimes you don't have to run your program to figure out there's a bug. Right? There are a lot of tools that can be used even before you commit the code. It can doing the static analysis of your code. It will say where all do you have a problem. So in our case, we use pre-commit hook, and on pre-commit hook, we have integrated certain tools. Right, example PyLint, so that everyone is following Python pip 8 base int. Black, so that code will be automatically formatted as for like pip 8 or other standard. Bandit, it is for common security issues. It's a static. It's also same thing. It does a static code analysis, and it will give you information regarding if there are any security issues that might have arisen. And we also use MyPy for a type set. Right. So on you guys can like there's one here's a link over here. I have given you a file. Currently, it's focused on Python, but you can have this kind of check like even before code hits production. So on this case, you guys can have more look into like pre-commit hook and everything. But basic idea is that before you make a commit message, all of these checks are done, and if anything fails, you will not be able to push. Until unless you fix that piece of code, you cannot even commit your code. Right. So CI/CD for our case it starts before you commit the code. Right. You have to make sure that the tool that we use is pre-commit tool. There might be other tools to use over here, but basic idea over there is that those tasks, those are lightweight, and you can easily do on your local computer. You want to make sure that that is done even before you do the commit. Right. So before the commit, we make sure that people have pre-commit hooks and all of these checks are done, and they fix the issue based on this one. After, yeah.
Bikram, just one minor thing. It seems like there's some rustling sound that's probably coming in from the jacket or something. I'm not sure.
Okay,
But
just
there
give
might
me
be,
a second.
if you can maybe just suggest. Thank you.
Is it better now?
Yeah, it seems okay now. Thanks.
Okay, sure. Yeah, okay. So that is regarding before you the commit. Now, once you commit your code into a repo, right, there are certain tests that are carried out that are a bit heavier and that will require some because you don't want to run all of your tests on your developer laptops, right? Some of these tests has to be moved to like server because they are a bit heavy. They take larger amount of time, and then some of these have to be still be moved into server because there might be some other integration. Right, you might need database, you might need other things. This is the step where like the CI. This is a step where CI kicks in. So as soon as you push your code, then on our case, what we do is we use SonarQt, right? SonarQt to do various of this check. We check for code smell. We check for code coverage. We check for duplicate, and we check for security risks. And on SonarQube, what you can also do is that you can say that if there is a like a security risk, then don't pass, right? Or if the code coverage is not 95%, then don't allow people to like go on the further on the step. So depending upon how critical the repo is, we set up different kind of labels, threshold for all of these. If these thresholds are not passed, then the code will not be like build. It will never go to like next step. It will not go to like scanning stage. It will not go to build stage, right? So for that reason, what we do is that for checking the quality of our code, we use SonarQube. Like you guys, it's an open source. Majority of the feature that you need is open source, so you can have it on your own server. Like if you need that, then ping me separately. I'll provide you the Docker file that we use to deploy this one, or you can have their paid plan. So first one is static code analysis, more on detail level using SonarQube. The second we use is SL scan. So what does SL scan do is it checks for any kind of vulnerability that is on the packages that we're using, because we use a lot of open source packages, right? And they might have some kind of open vulnerability, right? So for that reason, we use SL scan and we make sure that we do a dependency checks. Dependency checks means that all the version that we are using do not have any known vulnerability. We also check for any kind of secret check, right? So example, people might mistakenly put AWS keys or everything on the file. So we also make sure that these checks are carried out. And if any of these things is found, then it will just not allow you to build. It will just close it. Email will be sent to the person who committed it. They have to fix that issue and then push it one more time. And all of this step will like carry on. And then once you fix it, it will go to the next step. The next step is we build a Docker, right? So depending upon like mostly like on our case, like on 99% of the cases, using that code, and once all of these things are passed, we build that Docker file. Once that Docker file is built, we use that Docker file to perform like two tests. One is unit test, and second is performance test. For performance test, we use locust. It is on Python side, but these are the main two tests that we do. Along with that, you can also do about 5 different tests, right? I have resources for that one. Depending upon how critical your system is, like you can make sure that you run all these tests. And all of these tests might not run, example number 1 and 2, right? SonarQube and SL scan runs and build runs on each and every repository. But unit test and performance test might not run on some repository. Unit test usually runs on all the repository, but performance test might not run on some of this repository because these are not that critical. Example, if I'm going to deploy this into Cloud Run, then I don't have to do a performance test because I know like it can handle up to like 1,000 requests. And so depending upon what is required on that test part, you can remove it or you can add it. And so this is the steps, right? So these are the steps that usually happens on CI/CD pipeline. Now, if this steps has been properly completed, then what will happen is you have a Docker, you have artifacts, which is ready to be deployed, right? After CI/CD step is done, then that Docker is taken and it is deployed into testing. Right? The reason I told you guys that we need to have a 3 separate environment is for this reason, right? Because people will be working on different branches. You will have one main branches. You might have a release branch. You might have hotfix. You might be doing some hotfix. You might be adding some more features. So for that reason, we make sure that once that Docker file is made, it automatically gets deployed into testing. Right? Once it automatically gets deployed into testing, you can do an additional end-to-end test, because let me say on our case, we have about 5 different containers that are named after Pokemons, right? So these 5 different Dockers should be running for our web app to work properly. Now, let me say you push one piece of code, you finish, all the steps are working nicely, but once you deploy it into testing, things start failing, right? Either you figure that out based on your Sentry logs, or you figure out based on your log, or you figure out based on manually testing it. You can just roll it back and then fix your issues and deploy it into testing. So no matter what code you write, it will be directly deployed if all the steps on CI is completed. It will be automatically deployed to testing. After it's automatically deployed into testing, you'll have to make sure that you make a merge request into a like you have to, because usually I'll come to that later on, like how that branching name and everything is done. But if everything is good, then you will make one more, and your feature is completed, right? You have completed everything, you have done all the tests, you done all the unit tests, your code coverage, everything is good. Then you make a merge request and you send it to a different branch, and that branch will be deployed till staging, right? And for you to deploy into that branch, you need maker and checker, right? So testing, anyone can, you make a small change, you just push it, everything passes, it's on testing, everything is like ready. But to push into staging, there are certain steps that you have to do. You have to make a merge request. You have to make sure that you have to make sure that there's a maker and checker. Someone from the senior, the person who have not written the code has checked the code once. You merge it into that branch, and if that branch is accepted, then it will automatically make sure that it is deployed into staging, right? So testing and staging, mostly everything is automated. But to the master, like I said, this is a difference, right? So like I said, on our case, we only have continual delivery. We don't have continuous deployment. The part that differentiates our pipeline is only continuous delivery, because to make that change into masters, you have to make a merge request and everything, but someone has to like also do a QA, right? They have to make sure that a proper QA is done or report is generated, and that has been sent to like two senior people, and only these two senior people have the authority to merge it into production. Step is exactly same. There's no difference. I'll show you, like there's a diagram to show you that, but it's just that there's a change management. Before you can merge anything into like production, certain steps has to be followed up. Someone have to manually check it, and if they approve it, only these senior people, once they check everything, it will be deployed into production. That process, you just have a pipeline, you just click a button, and then it will just like say that, oh, now it's deployed into production. Process is automated, but there's a change management. There's a person who have to manually do it, right? So this is a continuous delivery. Same thing happens when you have to do a rollback. Let me say you made some deployment, and on production, unfortunately something happened. Then either you can send a merge request to like roll it back, or you can ask the person to deploy the old version. Send them the proper email and everything, and then they will make sure that they deploy the old, do the rollback and deploy the old version. So these are the steps that usually happens on continuous delivery. This is how it looks, right? So over here, if you see, like on the first one, the branch name is feature / something. So this will only be deployed till testing, and it's automatic, right? The second, that is the a bit more stable branch, that is always called testing. If you merge anything that you have done over here into testing, and if it is accepted, it will be deployed till staging. And master, if you see here, there's one more branch, and if you everything that is on testing is like testing is good, you have sent a merge request, someone senior has checked that code, then it will automatically deploy till here. But this will not be deployed, it will just show icons, like it will just show icons saying that do you want to deploy into production, and someone from the senior team will click it, and it will be deployed into production. And so this is usually how our CI/CD pipeline looks, right? All the checks in place. Certain branch can only be deployed into a certain environment, and then certain branch will require some permission to be deployed into production. This is one way of doing it, but there are different ways of doing it, which I'll explain in brief later on. So let's talk about, I talked a lot about our CI/CD, like let me also be careful about time. We talk a lot of things about like CI/CD pipeline. We talk a lot of things about all of these systems, but I just wanted to condense this into the best practices that we follow in DocSumo. We have 3 environments. We have different branches, right? So different branches where people can like, this is just like I said, this is just one way of doing it. There might be other way of doing it with release branch and everything, but this has worked really nicely for us. So people can work on any of these branches, right? They will merge it into testing if everything is good, and test is merged into like main branch. Now, when you are doing all of this merging and everything, all of this merging should have a proper MR merge request. There's a sample of merge request, and they also should have a proper versioning. Right? And regarding versioning also, like there's an article regarding where you can see and figure out how it can be done. Right? So that's one. And then on the merge request should always have these things. Few of these are automated. Example, code check, SL scan testing report are automatically put into the merge request. But for manual QA, you will have to get your Excel and put it over there. And the fourth thing that we also have, if you guys see our CI/CD pipeline, is we also encourage people to even push code if it is on work on progress. Because if you put work on progress on your commit, then it will not run any branches. It will just be there, but it will not run any branches. Right. So one practice that we have in DocSumo is if your computer goes down tomorrow, if you have to come to the office, then you should be able to pick up from where you left on the new computer. So we make sure that people always commit it at the end of a day. It's okay, the CI/CD pipeline will not run because it has certain like words that will not allow it to run, but the code is always deployed. And the fifth thing is, because you are deploying it into 3 environments, you have to make sure that your configuration and config files are properly set up as per requirements, right? So that you can deploy it into any version. So, and this is the resources that I was talking about. So there are mainly 4 resources. The first one has a very good guide on how to do CI/CD. The second one is the best practices that we have in DocSumo. Example, you have pre-commit hooks, sample of pre-commit hook, sample of our CI/CD, a sample of our deployment, right? And other best practices. That is second. The third one is how do I choose CI/CD? So this one is a very good article. And the fourth one is like how can you like do the versioning? And so that's mainly about the CI/CD in DocSumo. And if you have any questions about any of these steps, then you can contact me on email. And then this is my GitHub account. Yeah. So the first question regarding the branches strategy, like I don't know the exact name over here, but let me just go back to you. So this is the main.
Hey,
Yeah.
Bikram, Vaibhav here. I asked that question. I got the sense about your using feature branch, testing branch, and a main branch.
Yeah.
But I wanted to have this question. Why do we even need a testing branch? Why can't it be a feature branch directly to the main branch and you first merge it and then deploy that code, the main branch code on staging, and then
Yeah.
promote it to the dev environment? What it looks like is the branching strategy is tightly coupled with the environment,
Yeah.
right?
Yeah.
The expectation is staging and production should have the same code. Then why not
Yeah.
same branch?
Yeah. Sure. Totally true. Okay. Yeah. So that is one.
What?
And yeah. Okay.
So I wanted to understand why did you have a different branch testing instead
Yeah.
of using just a main branch and feature branch?
Okay, so the reason for that is because on the feature branch, you can also have like hotfix and you can also have bug fix. So main branch, we wanted to make sure that it's not polluted, right? The main idea about the main branch is that we wanted everything to be first done on because people are going to have like feature. Let me say I develop one feature called X feature, then I'm going to put it into testing, and that person can take it from testing, do his fixes. Like let me say I'm doing the feature Y, then I might do it on make a branch from testing, do it. The main reason was to make sure that main branch is not polluted with so many merge requests. All of this merge requests, whatever needs to be fixed, it goes on testing, then only it goes on merge request. So the only reason is like I would say not to pollute with too many merge requests.
So one other point, Vaibhav, which some people follow, uh, is when you have continuous deployment, the idea is that a check-in to a branch automatically means a deployment. Whereas when you disassociate your branch and your environment, then that becomes a explicit step. Hey, deploy this branch here, right? So this is one way where, and for example, in Heroku, right, whenever you merge to master, it Git push basically does deployment as well. So it's I guess I don't know if I'm representing it correctly, but is that the idea? So you know that okay, when I push to this branch, I know it's going to get deployed automatically.
Yeah, so on our case, like usually like over there, like you're right, if you think about it, like you can consider main and testing to be the same. The only reason, like the reason we decided to have two things is we don't allow people to push like in middle, like what you talked about, like on over there, like having a branch where people can do a hot fix into a master branch and automatically deploy it at the end of a week, right? So you have a branch just for deployment side of the things, right? That is not the practice that we do on our case because we have so many microstructure and everything, and not to pollute, right? And so that's reason we have this three way of doing it, and it has helped us a lot because
Okay.
people are a bit more careful before they merge into. They can do a lot of experiment because
Mhm.
testing is not that unstable. So because of that, we have it. But like you said, that is also a good strategy to have. Not
Yeah.
remove testing and do everything on master main.
Yeah, I think there is a couple of follow-up. Like I was so when there is a main branch, even there is a bug fix, right? You create a bug fix
Yeah,
branch, create
yeah,
a MR for main branch, get
yeah,
it approved,
yeah,
merge it, and deploy it on staging once
yeah,
works, and then deploy the same master or main branch to the
yeah,
production.
yeah,
Uh, so that's what I was thinking. Second
yeah,
question again with the same ideology is when we are in companies like us, right? Like testing infrastructure, staging infrastructure, and production infrastructure, all of them comes at a cost. And at most of the time, when staging environment, when you are
yeah,
developing, that makes sense, and
yeah,
or else it's just idle, right?
yeah.
So some of the questions that I was also thinking is, do we really need a testing or a staging environment? Uh, if or is that the only way we can, or what are the good ways we can prevent master branch from getting polluted without having a staging environment, or can we use testing as a staging environment? It's not a question but a discussion, maybe your point of view on how can we
So,
even reduce the cost
sorry guys,
of.
sorry guys, like I missed you because there's a power outage on my side. So
Mhm,
like I heard you till the staging environment is mainly idle, right? So
mhm.
till that, right? So can you please continue from
Right.
there? Yeah,
So, a discussion or a point of view from your side, right? Staging environment, most of the
yeah.
time it's idle. And
So
when there are
on
multiple
that
people
case,
who are
yeah,
developing, if it's a manual QA,
sure,
it's just waiting
yeah,
there. So, yeah, I wanted to
sure.
know your
So
views on how is staging, because how is staging very beneficial than having a testing environment, testing everything once everything is done, then merge it directly to the master and go ahead with production.
sure. Yeah, you're totally right. Even in our case, staging environment is ideal on a lot of times. But the trade-off that we have thought about is like the testing environment, like I said, right? So anyone can deploy till testing. Like even if you do a feature request or if you do a bug fix, people can directly deploy on testing environment, and that is very unstable, right? So because of that reason, like we wanted to have one staging environment so that even during the test phase or during the QA phase, or even in our case, what happens is that we also use our staging environment to do some annotation on documents because we get a lot of APIs and sometimes we are building some new APIs. And sometimes I want to test that API in more stable environment than my testing environment. So this really depends upon the organization. Like I said, I have 50 different repository, and for that reason, having a staging environment is worth the pain, even if I'm using it for 20% of the times. But someone else might feel that, oh, like my staging environment is more stable. I might not need my testing environment is stable. I don't do that many changes over there. So I can use my staging environment and
I think Bikram's having some trouble connecting. Uh, I think
over
Anirudh
there.
had some.
Let me just
Yeah. Uh,
yeah.
yeah.
So
Are you back?
yeah.
Yeah.
Okay. So I was just saying that that is just a trade-off that we have to we have to figure it out. But the best one that I would advise based on my own because I had also had removed staging environment at once to just save the cost. But later on, I realized that the is if even if it is costlier, the uh, when I have to do a deployment, having one stable environment where I can do a QA test and everything is worth the price. So that's the reason we have kept it, and I advise everyone to keep it.
Vaibhav, one practice that we do in our organization is we use ephemeral staging environments. So every every branch gets a separate environment that we can test on. So we set up a DNS with an alternate domain, and we can access the branch environment at branch.staging.our website. So with this, like we have some similar kind of environment, and we don't need to provision any specific infrastructure for staging environment.
One of the reasons, like we don't have a Dockerized infrastructure, right? So
Okay.
because of that, we have to set up different databases, queues, workers, all of that. Setting up always whenever we need staging environment becomes tricky. That's one of the issues that I like. At least we face. Any recommendations there?
I think Dockerizing would be the easiest way, but you might need to find alternatives for all the components that you mentioned in a Dockerized format, at least for your staging environment. So apart from that, I think else the other solution would be to have a specific infrastructure running for it.
Yeah, so like Anuj said, so basically, if you have something like Cloud Run, right? So one of the reasons we use Cloud Run is because our API do not have to get all databases. So we use like a serverless architecture, and we still have this many environments. But the beauty about that is I don't have any cost if I'm not using it. So even in that case also we have like all three environments. So this was the best practice on our case, and it really helps you not make any kind of mistakes, because if I'm testing and someone do a push, then how can I be confident that, oh, this branch is fully stable? So that's reason like we have different like three branching strategy and three environments. Okay, the next question was regarding Angular. So on the Angular side, my team has not like use like we don't use it, but I think if you search for internet, I think you should be able to figure out different tools, because usually the pre-commit hook is quite frequently used, and the one we have also we have taken it from internet and we have just modified as per our requirement. So I think you should be easily able to like figure it out for pre-commit hook for your language, right? Project getting heads out memory. Can it also? Okay, so that one, like unfortunately, I'll not be able to sell. Like in case of production build Angular projects, this is giving some memory error. But unfortunately, I'll not be able to help you on that because I have a bit less knowledge about Java, like Angular, because most of my infrastructure is on Python and on what do you call React.
There are a few other questions.
Oh, sorry.
I
Okay,
think from
sorry.
Anirudh. Yeah.
Yeah.
How do you manage your secrets? We currently use
Okay.
GCP Secret
Sure.
Manager.
Yeah. So we use GCP, and along with that, GitLab also comes with its own secret management. So certain secret, I just want it on certain branch. Example, my production JSON should be only accessible on master branch. So that's the reason like we have that. Like someone will not be able to deploy into master. You need senior people. So we handle it using GitLab's CI/CD secret management for different branches, and we also use GCP's own secret management for both for Kubernetes and Cloud Run.
Got it. And how do you fetch secrets from these places? So you mentioned GitLab and from GCP Secrets Manager. So how does your Docker file get the secrets while you build it during deployment phase? So right now we have a custom shell script that does it. So how do you do it?
So in case of GitLab CI/CD, it automatically fetches, right? When you make build the CI/CD pipeline, all of these variables are automatically provided, right? In case of Cloud Run, when I deploy it, I can make that link. It was only introduced about 6 months ago. Before that, they did not had it, and we used to manually do it, right? Either using script or either using because you just have to set it up one time, and then once that is set up, you don't have to touch it. So it was manual process, but now we have started using GCP secrets both for Kubernetes and both for Cloud Run.
Got it.
One other point, Anirudh, is secrets. I mean, ideally, you should restrict it to runtime and not during build time,
Yeah.
as much as possible. So, in which case, it's basically, if I don't know how you sort of run your stuff, but if it's like Kubernetes or something, you can use Kubernetes secrets to
Right.
for those things for your runtime stuff, and that you can pull using GCP.
Yeah.
Or I think AWS also has a sixth manager.
Yeah, and something that you might need during build time. Example, if I want to deploy if I want to install some internal package I have on Python, I might need that secret, and that secret you can handle it from GitLab CI/CD, like CI/CD secrets itself. Right? Some secret you can handle it from whatever tool you use. Usually they have secret management of their own, and on during deployment you can handle it from their own system.
Got it.
Okay, so there's one more question from Sriram. How is your front-end app deployed? Okay, so on this case, we deploy Dockerize. So basically, we do a build, get that file, put it behind Nginx, and then deploy it. Like currently, we don't use any kind of static CDCN. Like we just deploy it either on Cloud Run or we deploy it on the Docker, like that into Kubernetes, right? And then for files and everything, because they are automatically fetched through S3, there is no too much of the issue. And we use Cloudflare on the top, so it also does its own caching, right? So combination of Docker, cloud, for files, big file like images and everything, it is always fetched from S3 only. So like we don't keep it on the on Nginx, we directly fetch it from S3.
Thanks.
Okay. Monitor, how do I test one feature? Okay, so that is a part. So basically, that's one of the the last question that I have from is that testing environment, everything is mostly unstable. That's the reason we have a staging environment also, right? So usually what happens is that all of us get notifications, and sometimes because staging environment is usually ideal, and I know that I have to test this feature and I don't want interference from other people's, and other people code might break it. We directly push that into a staging environment and do all the testing into a staging environment, right? So depending upon what I'm building and depending upon can I really do that test on staging or not, and then do I need to push all of this feature into can I do a testing or not, or do I move to staging? If I am more concerned because it's a very critical information. Example, my data, the table structure, my JSON structure of the front end has changed, and that is going to break everything. In that case, then I will make the measure of the changes. Then I will push it into I'll push it into staging and do that testing on staging more than on testing. So that's reason I advise everyone to have 3 environments. Any other questions?
Okay. Thank you so much, Bikram, for this talk, and thanks everyone for joining us.
Okay.
I'll make the recording available later for in case someone is interested. But yeah, thanks everyone. Have a nice weekend.
Sure.
Thank you, Bikram.
Oh, sorry, it's Thursday. So
Have a nice day. Bye, guys.
have a good Friday. Okay.
Bye.